Hello guys, this is me again, Engineer Gaming, and for today's video will be a little bit different because today I'll be showing you some solution in regards to homogeneous DE. So I won't be dipping or going deep through homogeneous. I'm just going to be solving each one of them, okay? But we're going to go to them every step, so that you could understand every single step of homogeneous. Alright, so this is a little bit of a breakthrough of my gaming platform. So let's start. Alright, so the first example that we have for today, sorry about that, is 3 multiplied by the quantity 3x squared plus y squared dx equals 2xy dy equals 0. Okay, so this is an example of homogeneous DE because first and foremost, because of this term. Why? Because we cannot transpose this one to dy because this one consists of, sorry about that, y squared as well. So it consists of two variables. Of course, if there's y here, you cannot integrate this one fully. You cannot also integrate just the x. Okay? So otherwise, we can actually do the homogeneous tactic for this one. So there are only two terms that you need to remember. Number one is when m is simpler, okay, we will be using this one. Okay, so how do we know where is m? Okay, so m is over here, usually in the first term that is beside a dx. Okay, so usually they're in the first term. Once again, the first term, this one. We can actually transpose this one, then this one is also included. That is our m. And in this one, when it's beside the x, that's our m. Alright? And of course, the n is saying the otherwise when it is in the second term and beside dy. Okay? Right, so for today, we can actually see that this one is simpler. Why? Because it has lesser terms involved. Or we can see that this one is quite complicated when we're going to be multiplying this term. Right? So this one, just one term, like compressed into one term, and this one is like decompressed into two terms which has denoted by a plus sign. Okay, so this one is simpler, the n. You include the negative, okay? Alright, so when n is simpler, we'll be using this one. Right. So we'll be using y equals bx, wherein the dy or the derivative of y is equals to v dx plus x dv. Okay, so let's copy first this one. Sorry. Oops. Not that one. Back. Then I'm just gonna cancel the number. Boom. Right. So the only thing we need to do here is that all y, anything that you see y in the equation, we're just gonna substitute vx on it. And all the dy that we see, we're gonna be substituting these terms. Alright, so here we have y equals bx. So here we have 1y here. So we'll be changing that into vx. Okay, excuse me. And then this one also has y on it. So we can actually do vx as well. And then dy will be changing this one, this term, the derivative of y. Okay. So we have v dx plus x dv. Right. Oops, there. Okay. X dv. Right. After that, we're going to be simplifying first the term. Simple algebraic expression now. Okay? So let's copy paste this one. Okay. There. Okay. So over here, we can distribute this exponent of 2 to each terms because those are different in variables. So this would become v squared x squared. Right. This one would also become v squared, v x squared, because there are two x over here and when we multiply, we're just gonna add their exponent. Okay, so after that, for us to be, limiting or lessing the term, we can actually multiply both sides by 1 over x squared. Okay, so but first and foremost, we're gonna be separating or factoring out x squared from this term. Okay, let's copy paste this one. Once again, I'll be dealing with this step by step. Right, so we're gonna be factoring out x squared. There. And then we're gonna be deleting this one over here because once again, you factor it out. Right. Now, as you can see, we can cancel x squared here and x squared here through multiplying both sides by, let's insert first a fraction. There. We'll be multiplying it by 1 over x, where is it? X squared. Alright. So, upon multiplying this one, we can actually cancel it, no? Do I need to show it pa? But I guess not na lang. But okay, let's just show it. We'll be canceling this and this one as well. Right. So upon cancellation, we'll be only having, let's copy this one na lang. Or actually, we can just copy this one. That one. There. Okay, so x squared will be diminished in this equation because we just cancel out x squared to each side, and then 0 times this quantity is still 0, practically 0. And then the next thing we do is for us to determine if there is actually like like terms that we can merge, then we can actually multiply each side. No, we will be expanding each term. Okay, so how do we expand? Sorry about that. Okay, so 3, that will be 9. Oops, copy pa pala. Okay, so 3 times 3, that would be 9. And then we have dx, so 9dx, plus 3v squared, of course, dx, because this one is also denoted outside of the parenthesis, so we'll be multiplying it to this term as well. Now this one, we're just going to distribute this to each term, so this will be 2v squared dx, no? I'm going to delete this one, and then we're just going to put here 2b. Now after that, of course, you'll be seeing common like terms. So this one, no? Because they have the same dx and also the same variable with the same exponent. So how do we combine them? Simply 3 minus 2. So 3 minus 2, simply mawawala lang nito ng dalawa. And then this one will be out of the box. Alright. Then after that, we're gonna be this one, moving out or factor out dx. So that will be only remaining with 9 and the v. Okay, how do we do that? Oops, I'm sorry, this should be in negative, okay? Because this is distribute, then distribute, this should be negative. Sorry about that. There. Okay. After that, it's gonna copy this. Boom. And then factor out 9, dx. So this should be like this. Right. So after that, we can actually transpose this one to the other side so that this one will become negative. Okay. So let's copy this. Boom. And this one should be over here. 2bx db. Okay. So now, upon checking, we can actually perform now separable variable. So first and foremost, we cannot integrate this one, no. Why? Because there is a v and it's not paired with a v. It should be paired with a v or the same variable. So how do we do that? Well, simply by multiplying each side. Okay, fraction again. Let's insert some fraction. There. Okay. By 1 over this term. So that this term will be transposed into this term so that dv will be paired with this one. Okay. So it will be 9 plus v squared. Alright. And then over here, as we observe, there is also an x denoted next to dv. So we need to cancel out or remove or transpose x to the other side so that dx and x would come together. So how do we do that? multiply 1 over x. Okay, so upon simplification, we will be deriving, we're just gonna, insert a new equation because, okay, there. So over here on this side, focus on this side first. Numerator will be dx in this, just in over here, and then at the denominator we'll be having dx. The equal sign, another fraction over here, okay. And at the numerator on this side will be remaining 2b dv, right? Because we're only just eliminating the variable x. And then, of course, at the denominator, we will be having this term because we multiply both sides, okay? So 9 plus v squared. All right. Now we can perform integration so that dx and dv would be eliminated in this equation, right? So in order to get our general solution, we need to integrate both of these. So how do we integrate? So let's copy this one lang muna. Then let's insert equation and then integration. There, and then equals, and then another integration of this one. Okay, since the font is shrinking now, we're just gonna zoom in out a little bit. Okay, there. So of course this one, simple integration, this is just 1 over x, so this one should be ln x. Okay, so let's insert over here again. Equation. So this one is simply ln x. Okay, so it's up to you. Oh, that's why it's too bold, because it's actually in bold. Okay, ln x. So it's up to you if you want to put an parenthesis like this, but it doesn't make, it's just the same, okay? But for the purpose of discussion, then I'm just gonna put the parenthesis. Okay, this one, let's put the equals. Of course, you can actually perform the u substitution. So how do we use this u substitution? Okay, so let's do this one. Only this, okay? Focus on this one. Let's highlight this one. Okay, focus on that one only, okay? Since we already integrate this part. Okay. So if we're gonna be using u substitution, we're gonna be doing let u, oh, it's already, let u equals this term, okay? Okay. Of course, you know this one. It's basic differentiation. Basic integration. B, then square. Right. Now that we have the u, of course, we're gonna be having also a du. Okay, and du is equals to, derivative of this one, simple as 2b dv. Right. So what do you observe? We have 2b db here and a 2b db here. We also have 9b squared here and 9b squared here. So we're just gonna denote everything and substitute these values to here. So what will happen? So that will become, okay, let's, do we have there, and then fraction. Okay, so we will be having du, since this one is 2b, dv over u. So 1 over u simply as ln u. Very good, ln u. Okay, let's put parentheses. Now ln u, we need to substitute back the value of u. So this would become, you guessed it right, ln 9 plus b squared. Oops, ang dami nun. Okay. Now that we have this one, then we can transpose this one over here. And of course, upon integrating, don't ever forget plus c. Right. So this doesn't end our solution yet, because we still have both ln on both sides. We can actually cancel it out by by making it as exponent of e. Okay, how do we do that? Simple simplification only, okay? Maybe we just use another one na lang because there is an e in script. So e raised to this one, boom, okay? And then equals this one also, okay? You include plus c, okay? Okay, that would be e raised to this one, right? Now, as we all know, we can decompose this one, no? Let's decompose this one. We can actually rewrite this one as e ln of this multiplied by e raised to c. Okay, so let's show it so that there will be no confusion. Oops. So we'll be remove plus c, but we'll be multiplying. I think we're just gonna use times. Can we use this? No, it's x. Let's find something like a dot. Insert so that won't give any problems. Do we have? Yeah, we do have. Okay, that one. That would work. Then e raised to c. And this one, e raised to c, can be also denoted as simply as c. Okay, because anything that you put on or raise on to c, it will be also c. Okay, so we can actually deal this one as c only. Okay. Oh, you know what? Let's just do this one first, and then let's copy paste again for the sake of discussion, no? Because we need to deal with it step by step. This one will be C. Alright, now this one we can now cancel E and Ln, also here E and Ln. So we will be only left with this one without Ln. Oops, there. Without the term Ln. I don't know if I can cancel Ri. You know what? We'll just write it out again. Because, and then we have multiply by C, so C times 9 plus B squared. So do you think we're done? Not yet, because this one is still denoted as B, not in terms of Y. So we'll be finding first the value of V. So we substitute it over here. Now this one. How do we get it? So let's just put it over here na lang. There. So we can use this one, no, to find the value of y, simply as, or I mean, find the value of v. So v is equals to equation fraction equals to divide both sides by x, so y over x. Okay, so this one, this v over here will be transposing v over x. Okay, this should be like that. Okay, I mean v over x, y over x, since v is equals to y over x. Then simplify it further. No, we can actually simplify this one furthermore. How do we do that? Copy paste na. So exponential, both will be affected. So this one would be y squared there, and this one would be x squared. Right. Now we can still, oh no, we're going to be canceling out. You know what? It's fine. Okay, over here we can still simplify this term, but I don't know with I don't know with some of the professors, I guess they accept this kind of formula already for the general solution. But actually we can still simplify it furthermore. 9 plus this one, we can actually find the common denominator, which is x squared. Okay, so let's perform that. I will just use this one. Let's just copy paste and rewrite it again. There. Okay, the fraction. Okay, just then fraction. Where is it? Equation to fraction. Okay. So over here at the bottom, the denominator, the common will be x squared, of course. Now x squared divided by 1, since this one has over 1, then times 9, that will be 9x squared. Plus x squared divided by x squared is 1, so you will be left only with y squared. Alright. Now, of course, we're not yet done. After this one, we can still simplify furthermore. How? Oops. I think I should tab there. By multiplying both sides by x squared. Oops, we didn't square it. Sorry. Oh, what's happening? There. Why is it not racing? Again, x squared. Or maybe it's outside of the equation. No? Let's do it again. It's outside the equation with there. Okay. There. There. And then x raised to 2. There you go. Of course, we'll be canceling our x squared over here and multiplying to the other side. So we'll be left with, let's just make another equation. We'll be only left with x cubed y, because x squared times x will be x squared. So x cubed is equals to, well, this one will be already diminished from the equations. It's already cancelled out by multiplying both sides. So we'll be left with c times 9x squared. Oh, this should be 9, sorry. 9x squared plus y squared. And that's it. We already got its, here's an arrow, okay, its general solution. So this is our final answer. Right, hopefully you catch up with me, no? Because homogeneous is really, really long in terms of solution itself. But actually the simplification, you can just skip some of the steps and then just do it with your mind. So if there's actually a given boundary, then we can actually substitute those boundaries to those x so that we can find the value of c. And since we're only given a equation without a boundary, so we can only get its general solution. Alright, so I think that's it for just today's video. I'll be giving only one example each day. So this again, Engineer Gaming. Like and follow for more.